Hello everyone. Our project is the development of 3D modeling gallery based on the virtual reality. 3D modeling is a fundamental process for the industrial manufacturing and is an essential skill for the designers and the engineers engaging in design activities. The traditional course of the 3D modeling is usually delivered through the briefing lectures and computer practices. The lecture delivers knowledge mainly by the projected slideshows or real-time demonstration. However, this teaching approach does not fundamentally change the limitations of traditional teaching or maximize the students' initiative to learn the 3D modeling. In recent years, the combination of VR technology with education has also gained recognition and popularity. VR shows promises to benefit 3D modeling courses with irresistible advantages. For example, learning modeling in VR breaks the limitation of time and space, allowing students to enter virtual scenes and to experience the 3D modeling. The students' learning process can also be accelerated by feeling the scale and depth of the 3D models and experiencing the modeling concepts and methods in an immersive learning environment. Immersive technology, such as virtual and augmented reality, is currently a very promising tool and is increasingly used in a variety of fields. Most industrial design students still learn 3D modeling, use a traditional learning method, which means lectures demonstrating the modeling process and modeling operations through the slides. The conventional lecture-style seating arrangement used in 3D modeling education can result in inflexible learning, as a singular and unchanging teaching method can limit students' ability to experiment and develop their own ideas. For 3D modeling education, VR breaks the two-dimensional space of the traditional computer screen and brings students to a new dimension of experience and interaction and a higher level of engagement. The aim of this project is to develop a 3D modeling gallery based on the virtual reality that can gamify the modeling lessons through a virtual campus scene to inspire users' interests in modeling and allow users to manipulate the model in the 3D modeling gallery and understand the construction of the 3D model and gain the modeling instructions. The first main feature of the 3D modeling gallery is the virtual campus scene that allows students to explore the 3D modeling through the virtual models of their campus buildings, shown in the two figures. In order to provide students with an immersive learning experience and improve students' motivation for the learning 3D modeling, the virtual campus scene in the gallery was built with reference to the author's campus. By scaling the real scenes to an appropriate scale as virtual scenes, and reconstructing each of the building's models, the students can feel the novelty of the 3D modeling and be inspired to learn this skill. The proposed system provides two movement options in the virtual campus, including joystick and teleportation. Students can walk freely around the scenes in the virtual environment and navigate the vibrant virtual campus. When touring the virtual campus, students can switch between the joystick movement, which is more precise but slower, and teleportation, which has larger steps and is suitable for longer distance. The practice showcase of the 3D modeling gallery is located at the Gate of the Wisdom, a landmark in the center of the source campus of the author's university. Students can interact with the 3D model by using the VR controllers, which will appear as the virtual hands in the scene. When the virtual hand meets the 3D model, the controller provides a vibration feedback to indicate that it is ready for grabbing. After grabbing the model, the users can freely manipulate it by rotating it in any perspective or moving it either closer or further to observe all the modeling details as presented in the first figure. When the students want to see the process of modeling of the 3D model, they can use the right controller to point at the model and pull the trigger. The model will change to the initial state in the modeling history. The second figure shows the state ready for the demonstrate the modeling process. If the user gets confused about any of the modeling stage, They can use a virtual hand to press the tips button in the scene. When the button is pressed, the operation performed at the step appears on the model, and the part that changed due to the operation is highlighted in yellow color on the 3D model, providing the user with virtual accurate tips shown as the third figure. The user test including 2 phases. In the first phase, participants learn how to model using traditional instruction method and finish the survey. In the second phase, participants use the 3D modeling gallery to study modeling and finish the survey. As shown in the figure, the experiment results show that in 3 aspects: ease of understanding the model, confidence in completing the modeling exercise, and interest in modeling. The combination of 3D modeling gallery and the traditional learning demonstrate a significant advantages over the traditional learning method alone. Moreover, in terms of the efficiency of the learning process, the result indicates significant advantages of combining 3D modeling gallery with the traditional learning. In conclusion, this study developed a VR system for educational purpose to assist the learning of the 3D modeling for design and engineering students. The whole system is based on the virtual campus, which allows users to move freely through the scenes of the campus, wearing a VR headset and touring the campus. The practice showcase in the system is designed for the students to freely select the model from the module practices they want to view and manipulate, better understand the construction of the model, and obtain the modeling guidance. For the future work, another feature to be added in the gallery is a virtual photography studio for the lighting in the rendering of the 3D model, which allows students to freely move the position of the lights and set different light intensities in the VR environment to learn about lighting in rendering. That's all of the presentation. Thanks for watching.